OSI layer or Open System Interconnection layer. So the problem statement is that when two systems which are completely independent, they want to communicate with each other. So a Windows system cannot communicate with a Mac system until they follow a common set of protocol. Before the OSI model, each OS vendor had their own set of protocol and they used to communicate with each other. So Windows used to communicate with a Windows laptop and Mac used to communicate with a Mac laptop without any problems. In fact, still the Mac has their own proprietary protocols like AirDrop or AirPlay, where only those supporting devices can integrate with the Mac devices. So to overcome this, they had to have a set of protocols which are common to both OS or common across different OS, different platforms for sending the packet from one device to another. But to send a packet from one device to another, there needs to be a lot of protocols working in hand with each other to send out a packet. For example, you need a protocol to get the data from the user, right? And then that data has to be passed down to the below protocol for packaging, and once it is packaged, that needs to be given to the another protocol for addressing, and then given to another protocol to get the medium and transmit, right? So there are so many protocols working together to send one packet out of one system and similarly receive the packets and decrypt it or decode it and send it to the user, right? Since there are so many protocols working together, so what was done is categorize this protocol based on the job they do, and we call them layer, and that's how OSI layer was born. For example, all the protocols which are used to get input from the user are called application layer, right? So all the application layer is nothing but set of protocols that is used to interact with the user and get data from them. So similarly, there are many other layers and each layer does a particular job. So each layer has a set of protocol that does a particular job. So that is how the OSI model is defined. Okay, now we have understood what is an OSI layer. Let us go in each layer and understand what they do and how they do it. So before moving on, one easy way to remember the layers of the OSI model is please do not throw sausage and pizza away. Okay, so physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Okay, so we shall go into the application layer. So what are the different kinds of application layer protocol? So these are all the protocol: HTTP, HTTPS, FTP, SMTP. And the Google Chrome you see here, they are the application, they are the app which the user uses. So you see a button, you click it, you type google.com in its tab or in its search window. So all the look and feel are given by the Google Chrome, but as soon as you type enter, it has to use the HTTP, HTTPS protocol to get the data and send it out, right? And similarly, FTP is a protocol name, file transfer protocol, and there are many applications that use this. For example, Windows SCP or WinSCP or SFTP. So all these are the applications which the user uses. So the interaction is with the app. The app in turn uses the FTP protocol to send the data or receive the data across. SMTP is again simple mail transfer protocol. So this is for emails, and Gmail or Yahoo or any other mailing system uses SMTP protocol. So that is why you are able to send mails from Gmail to even to yahoo.com, right? Presentation layer. So all the data coming from the application layer will be in terms of big messages or images. So all those texts have to be converted into bits. So that is where presentation layer comes into picture. We use different protocols like ASCII or Unicode to convert the data like pictures or text into bits, ones and zeros, right? And then these bits are compressed so that it takes lesser time to transmit around the network. And encryption, so we encrypt the data for better security. So these are all the jobs of the presentation layer. Session layer. So what is the use of the session layer? Let me explain it with an analogy. Think that there are two big dons who want to have a secret meeting with each other, but they don't trust each other. So their assistant will help them in setting up the meeting, make sure the place is safe, and when they arrive, they check each other to make sure that they're not carrying any dangerous weapons, and they make sure the meeting goes smoothly, and the meeting is done, they close it and they leave. So this is exactly what session layer also does. So once you log into your banking website, so the session layer in your system make sure that it is the right banking website and it is not a duplicate site where somebody is trying to extract the money. And similarly, the banking site verify that it is really you and it is not somebody else with your rogue password or rogue username. Okay, so the session layer make sure the handshake happens. So they try to set up a meeting between you and the banking website. Okay, and once this session is created, they will have a certain time called session timer. So you might have seen that in a banking website there will be a timer running in the right hand side corner, which we call it as a session timer. So if you don't do any activity and the timing is idle, so the session will be done. So that means you will have to re-log in again. So every time you log in, a meeting is created or a session is created. During that session you can do your activities, and once it is done, your session is closed. So this is what the session layer does. Make sure that you meet with the right person and get the job done. So this is the job of a session layer. Next is the transport layer. So think that you have a system or a laptop with so many tabs open, right? One is doing Google, one is doing Facebook, one is doing WhatsApp, so on. So everybody is going to send the data through the same protocol links, like data link, physical layer, the same physical layer. So all the data is going to come and accumulate with the operating system or the machine. So how is this operating system going to decide which data belongs to which tab? So that is where we come up with something called port addressing. So every time a data is being received from this tab, let's say google.com is coming from this tab, so the operating system would take it to the transport layer and says, can you pack this up for me? So the transport layer would add something called a port address to it, and then followed by the data. The port address will be a header. We call this header. An extra set of data is called header. So port address will be added in the header, and then this whole data is sent out, right? And while receiving, the receiver will again copy this port address and send the data back to it. So when the OS receives, it checks the port address. It knows that this is the port I have sent out and this is the port I am getting. So here the transmitting port, let's say, is X and receiving port is Y, and over here the transmitting port is Y and receiving port is X. So it knows that the receiver port is X. So who has the receiver port? Whoever has asked for it. Transmitting port is X, so you got the data for this port, that means for this tab. Okay, so you have many tabs open, everyone gets a different port addressing, and everybody, once they receive the data, the operating system or the network layer asks the operating system to verify whose port is it, understand which tab gets the data, and forwards it to that particular tab. So that is port addressing, segmentation and reassembly. So you have a large chunks of data coming from the above layer. We cannot send it as such because the data link layer or the physical layer is error prone, and once there is an error, you will have to resend the data. So it is better to send it in the small chunks, to cut the data into pieces and reassemble them at the receiver side. This is also one of the job of the transport layer protocol. And reliability. Once it comes to reliability, we have two options. One is TCP and other is UDP. Okay, TCP is reliable protocol because a handshake is being created by the sender and receiver. So once a packet is sent, the receiver sends an acknowledgement to it. If the data is not received, the sender has to resend it. So it is very reliable. But UDP, the transmitter just sends the data. It doesn't care whether the receiver has received it or not. So UDP is faster than TCP because of the overheads and other things, but it is unreliable. So if a data is lost, it is lost. It has to be retransmitted all over again. Okay. Flow control. So what is flow control? Suppose you have multiple tabs open and your system is getting slow. So this tab, which say you are browsing some data, so tells the transmitter that, see, my operating system has got slow. I'm not able to process your data so fast. Why don't you reduce the speed, right? And so this server will reduce the speed which this port is accessing. Okay, but some other ports over here might get a higher speed. That depends, but only for this port we will be reducing the speed. Error detection. So if there is an error in this connection, in this port, right, then what happens? So this error is detected and we tell the server that there is some error in your data. So how is the error detected? We have something called a footer. In the footer we have something called checksum. So this checksum checks if all the bits are right, and there are some mathematical calculations to it. So if there is an mismatch, the checksum will not match with the data. So we say that there is some error and we don't know what the error is. So we say to the server, there is some error, checksum is not matching. So you will have to resend the data again. So this is error detection. And remember, all these error detection, flow control are per link, per port, and not for the whole system. Now we come to the network layer. So network layer is responsible for addressing whom to send the data to. Now it has got the data from the transport layer. Now it has to be packaged and sent it out. So its main function is to address. So whom to send the data to, right? So how the address is designed is that you see this is the door number, while all the others are all pointing to a broader area, which is Bangalore or Mathalli or India, but this is your particular house. So similarly we have something called host address, which is this is your particular laptop, while all this is your network address, right? So there will be many laptops or computers in your network. So 192.168.1 will reach your network and .10 will reach your PC, right? So this /24 tells how many bits is network and how many bits is host. So /24 means these three will be your network and this will be your host. Okay, so each of this is 8 plus 8 plus 8. So 8 plus 8 plus 8 bits, so 24 bits. So the first 24 bits represent your network and the last 8 bits represent your host. So what is this address called? This address is called IP address. Okay, and who gives the IP address? So whenever a client or your phone connects to an access point, the access point gives an IP address to it for a certain amount of time, let's say 1 hour. So after 1 hour, the client again has to ask the AP, give me another IP address, right? So this is configurable. Sometimes they keep it for 12 hours, sometimes they keep it for 1 hour. The basic idea is IP address of a device keeps changing. So it can change as and when you connect to a network. Suppose you go to your office, you get a different IP address, right? And you come back home, you get a different IP address. You connect your neighbor's SSID or neighbor's network, you get a different IP address. So IP address always changes for your device, and that is why this is called a logical address. This is not a permanent address. So it just says where your network is at that point of time, in which network your client is associated to at that point of time. You change your network, the IP address changes. So now we know how you get your address and what it is. Now next we will see how the packets reach the network. Okay, sure. So now we know how the addressing works, right? So the network layer is responsible to find out what is the end address. So there are many protocols to find out. So you type google.com, we don't know what is the address of google.com. So the networking layer is the one who asks the DNS server, and there are certain protocols running to tell us what is the address of your ending system. We will get to it as and when the lecture progresses, but just remember that the network layer will be able to find out the final end destination networking address, and it will put it on your package. So your data comes from the transport layer, again network layer adds its header, right? So it will pack it more. The network layer adds a header. In the header it will be having a to address and a from address. To address is your final IP address, right, of the google.com, let's say, and from address is your IP address, so that the google.com, once it wants to reply, it just have to send it to your address. Okay, so it has formed the networking, it has formed the network address, and it has put it in the header, and then it sends it out to the layer below, which is the data link layer. Okay, now that you have a package and you have an address, so how is it going to reach? So you will have to send it, pass it across from one device to another. So how is the device going to take up your packet? So we need to specifically address it and tell them to open the packet and see. For example, this person has to call her by the name. Let's say her name is Joanna. So he has to say, hey Joanna, take this package. And Joanna has to open the package, see that the IP address is different. It's not her IP address. So what she's going to do, she's going to pack again and send it to Tim. Let's say Tim opens and Tim sees it's not my IP address, so he will send it to somebody else, so on. So we have to send it to the next available person, and the next available person's address has to be a unique address, right? And that's where the data link layer addressing comes. We call this MAC address. MAC address are all unique. Every system in the network has their own unique addressing. There is no other system with the same address in the world. Okay, so this makes sure that you send a packet to her, it reaches only to her. Nobody else is getting confused. Okay, she thinks, okay, this package is for me. She opens it. And she sees that network IP level addressing is not hers. So she has to pack and send it across. So this MAC address helps in sending the packet from one device to another and passing it on until it reaches the final destination. And error detection. Suppose there is an error while transmitting. You have an access point and you have a phone, right? And there are some errors while transmitting the packet. The bits are mismatched. The phone has to say to the AP that, hey, I have lost some packets. Can you retry? We call this acknowledgement, right? The phone tells the AP, I have received so many packets, but I have missed 3 packets. So the AP can resend those 3 packets again to the phone. So this is error detection and flow control. So the phone can talk to the AP and say that I don't support very high bandwidth. Why don't you reduce your speed? Right? And AP has to reduce the speed and adopt to the phone's speed. This is the flow control. Access control. Okay. When you want to transmit a data in Wi-Fi or Ethernet, we have to make sure that we don't collide with any other data packet. It is something like our Indian traffic system. You see left and right. If there is no data, if there is no vehicles coming, you just zoom out, right? So it is very similar, but it will be a little more organized because you wait for a certain amount of time before making sure that there are no other data packets in the air or in the Ethernet cable before sending your data packet out. But of course, it is not fully guaranteed that there will be no collision. There will be collision, and once there is collision, you'll have to retransmit the data. The MAC address which I was talking about, this is called the MAC address, right? And it is a 64-bit MAC address. Okay. And these are all very unique. For every device there is one particular MAC address, right? And it is never repeated.